Hello everyone, I'm Mark Hands from Goldfields Library Corporation, and I wish you a very warm welcome this evening to a very exciting session with Kirsten Banks. Hello Kirsten, a very warm welcome to you tonight also.
Hello, good evening.
Hi. Now, we're doing something really clever, which is working reasonably well at the moment, in that we're having both a Zoom session and a YouTube session concurrently. So on YouTube, what you'll see is the first slide of Kirsten's presentation. There will be an opportunity after Kirsten's presentation to ask some questions, and please feel free to pop them in the chat. And I can see Lou is already, hello everyone, I can't wait to start, so excited. I absolutely agree, Lou. Very excited. So I will start really quickly by acknowledging that I'm here on Dja Dja Wurrung land, and I want to pay my respects to elders past, present and emerging. But I know that Kirsten isn't on Dja Dja Wurrung land. She's coming to us from up in Sydney. So I will hand over to Kirsten now for her acknowledgement and presentation. Thanks, Kirsten. I'm very excited for this.
Thank you, Mark, for the wonderful introduction. And thanks for being here despite COVID having everyone locked down in Victoria and in Melbourne at the moment. So before I begin, I do want to give a special shout out to those tuning in from Victoria. I hope you're all doing well and staying safe during the second round of lockdown. Thank you all for joining us tonight. I'm so excited to share my passion for the stars with you. And I feel so privileged to have the opportunity to share some stories from my Aboriginal heritage with you tonight. Now, just a few housekeeping things. If you have any questions, please feel free to put them into the chat, either on YouTube or if you're lucky enough to be in the Zoom chat as well, chuck it into the Zoom chat. We will be using these chat options throughout the presentation for a bit of interactivity. So it's not just going to be me talking at you the entire time. We're going to actually have a bit of a conversation, where we'll try our best, given the circumstances we're going through YouTube and Zoom tonight. But please feel free to use those chat options and we'll have lots of fun. Okay, we'll have a nice Q&A session at the end as well. There is a lot of us tuning in tonight, so we may not get to all of your questions, but we'll certainly do our best. And Mark will help me out with that throughout the evening. So anyway, without further ado, let's get started. So first of all, I would like to pay my respects to the traditional custodians of the land that I am situated on. They are the Gadigal people of the Eora Nation. I'd also like to pay my respects to the elders of this land, both past and present. This land was never ceded, and this always was and always will be Gadigal land. And given that we're tuning in from places all around the country, I'd also like to extend my acknowledgement to all Aboriginal nations and the elders past and present, and to any Indigenous, Aboriginal, Torres Strait Islander people attending this event tonight. We are here, we are proud, and we matter. So, if you don't know me, let's get acquainted. My name is Kirsten Banks. I am a proud Wiradjuri woman with an undeniable passion for space and astronomy. I was interested in the night sky from a very young age, and when I was in primary school, I actually wanted to be a meteorologist and study the weather, like the people on the news. But in high school, my passion moved from the clouds to the stars, ever since I watched the Hubble documentary about the Hubble Space Telescope. From that moment forward, I knew that I wanted to learn more about the universe. I needed to learn more about our weird and wonderful universe. So I went on to study a Bachelor of Science with a major in physics at the University of New South Wales. And now I've started my PhD studying galactic archaeology. Basically, imagine Indiana Jones, but in space. And that's basically what field I'm researching in. I'm studying the stars in our Milky Way galaxy to learn more about the formation and history of our island universe. Kind of like how an archaeologist would study artifacts on Earth to learn more about the history of a particular civilization. But on top of that, of my passion for the stars, I also love talking about it as a science communicator. So my passion for public speaking kind of came out of nowhere for me though. Last year in April, I gave my first TEDx talk at TEDx Sydney Youth, which you can see a picture of that on the screen right now. In primary school though, and in high school, I would have never thought I'd be speaking in front of hundreds of people on a big stage or going live on TV in front of thousands of Australians or being right here with you this evening. Because when I was younger, before any sort of public speaking assessment at school, I would just absolutely freak out. I would sweat, I would shake, and I would just not want to do it at all. But now I love it and I could never look back. So now allow me to communicate and share my passion for the stars with you tonight. Before we get started on the sky though, I would like to first introduce Indigenous Australia. If you thought Australia was multicultural now, even before British settlement, the land we now call Australia was the epitome of multicultural. There are over 250 Indigenous language groups that make up Aboriginal Australia, and every single one has an intimate connection to the night sky. And each one has a unique perspective of the stars and the planets, which plays an integral role in ceremony and interacting with the land and the people. Now, some of these perspectives can overlap, which you will see throughout tonight, but others are completely different. And that's what makes Australian Aboriginal culture so beautifully diverse and strong. Now, my family comes from Wiradjuri country, which is now what's more commonly referred to as central New South Wales. Wiradjuri is the largest Aboriginal nation in New South Wales and one of the largest in Australia. Our lands extend from the Murrumbidgee River down south up to the Macquarie River in the north. Now tonight I will be sharing stories from my Wiradjuri heritage, as well as a few other traditions from Gamilaroi and Wirgaya nations as well. And I'll let you know which ones are from where. Now let's start with a blank view of the sky. Remove all preconceptions that you may have and see the sky as a blank canvas. What you can see here is a wide view of the night sky during the Australian winter, with the bulging center of the Milky Way galaxy centered on the screen and stars speckling across the entire view. You can see this sort of view for yourself, like on the screen right now, by downloading the computer program Stellarium. It's a fantastic program. I definitely recommend downloading it. It allows you to see what's up in the sky from any location on the Earth at any time. You can go into the future, you can go into the past. And another fun thing that I like to do with Stellarium is to go to Mars and look at the sky from Mars. And on top of that, you can even look at the Earth through a telescope from Mars too. It is really fun. So I definitely recommend downloading Stellarium. It's free and you can download it onto any type of computer. So when we look up at the stars from the Earth, generally we can see some patterns in the sky. We use our powerful imagination to connect the dots and manifest images of godlike beings, animals, or objects in our day-to-day lives. And these are called the constellations. So let's start with something familiar and have a look at the Western constellations. In the Western perspective, all constellations are a collection of two or more stars connected together by imaginary lines to create some sort of image or pattern. This is actually called an asterism, and the region around the sky, or the region of the sky around an asterism, is called the constellation. And there are 88 modern constellations, as you can probably see a few notable ones in there, like Scorpius, Libra, Virgo, and the Southern Cross on the screen right now. Now, the Indigenous perspective of the night sky does have a few similarities with the Western perspective, but like I mentioned earlier, there are a few differences that might surprise you. Before we take a look, I'd like to play a little game. So get yourselves ready on the Zoom chat and also in the YouTube chat. Okay, we're going to play a game of Guess That Constellation. Now, you don't have to know exactly the name of the constellation I'm going to show you, but I'm going to show you a constellation and I want you to try and figure out and guess what you think it's supposed to be. What do you think it might look like? Okay, we'll start with an easy one first and then move on to a bit of a more difficult one. Okay, type yes into the chat if you're ready to go. Okay, we have a few yeses in the Zoom chat. I think YouTube is a little bit delayed behind us, but I'm sure people are all ready to go and very keen to check it out. All right, fantastic. Let's go. I'm going to give you an easy one first, then we'll go for a bit of a hard one. Let's do it. What do you think this constellation looks like? Oh, it seems to have stumped a few people. We have a dog, a dingo. Taurus, also a dog. Dog seems to be pretty common here. Sagittarius, it could be Sagittarius. Lots of dogs. This is fantastic. An upside down dog, very specific. I like it. A lizard, Scorpio. A crab. A deer. A goat. Lots of very great answers. A dachshund, very nice. Okay, there are lots of great answers, and looks like the majority of you are correct. It is indeed a dog. It is Canis Major, the big dog. So it is actually an upside down dog. So well done everyone who guessed dog. And well done to everyone who guessed other things too, because you're using your imagination, and that's all I can ask for, which is fantastic. Now, a few things about this constellation, Canis Major. It is the big dog, and you can see this very bright star here around the neck of the dog. This is the dog star Sirius, which is the brightest star in the night sky. It's about 8.5 light years away, and it's actually 2 stars, not 1, which is pretty cool. All right, so that was a pretty easy one. Okay, let's try a bit of a harder one. Okay, what do you think this constellation is? I'll give you a few moments to try and figure out what it might be. A snake? It could very well be a snake. It's very abstract, isn't it? A worm, a stick, the pointer, a lightsaber. I like that one. The dipper, a rod. Lots of great answers here. None have been the right answer yet, though. A river, I like the river, that's fantastic. An arrow, a spear, a line. Janice, a line, look, you're quite right. It definitely is a line. But what does this line represent? A belt, an eel, a wand, a minus sign. Oh, it's another great one. Song lines, I love that one. Emma from Zoom. A path, a broom handle, I like that one as well. Gemini. Okay, no one has guessed it yet, but are you ready? It is Canis Minor, the little dog. It is also a dog. Oh, I see actually someone did guess that in the YouTube chat. Well done. So this is Canis Minor, the little dog, who apparently only deserved 1 line. The poor thing. So there we go. Now that we've all warmed up a bit, we've gotten a bit more comfortable with ourselves, let's go back to our blank sky and try and have a look at Indigenous astronomy. So again, put any preconceived ideas out of your head and be willing and ready to take in the beauty and uniqueness of Aboriginal astronomy. So I am going to share with you now the different types of constellations that are identified in Aboriginal astronomical traditions, and there are 3 of them. I'll start with the most similar type of constellation in the Western constellations, and then move on to the more abstract ones. So first things first, the first of a constellation from Aboriginal astronomical traditions is just the same as the constellations we see in the Western view. That is, a collection of stars creates a pattern or an object. Now, this particular constellation of stars and collection of stars in Western astronomy make up the constellation of Orion, who was a great hunter from ancient Greek astronomy. In Wiradjuri astronomy, those same stars make up the creator spirit Bayami. Now, what's interesting about Orion and Bayami is that they are in the same orientation. So let me explain why this is interesting. If you're from the Northern Hemisphere, you'd be used to seeing Orion standing up tall and strong. However, from the Southern Hemisphere, Orion is seen upside down. And this is due to our relative views of the night sky on our round Earth. And you would think that Bayami would then be depicted in the opposite direction of Orion, such that he stands up the right way. But there's actually a story, a great story from my Wiradjuri traditions, that speaks of Bayami chasing an emu. And while he's chasing the emu, he doesn't see a log and trips over it. And as he trips over it, that causes him to fall flat onto his face, headfirst into the ground. Now, while that seems like a quite humiliating story for the creator spirit, this is actually represented in the night sky. As the stars of Bayami, or Orion, set in the western sky from the view of Australia in the southern hemisphere, the head goes down first. And this represents Bayami falling headfirst into the ground. And that's one of my favorite star stories from my heritage. So in this sense, the night sky is kind of like the canvas for our stories. It illustrates those stories and helps us learn these lessons that come from within the story. So there you have it. The first type of Aboriginal constellation is a collection of stars to create a pattern or an object. Okay, here's another set of constellations that you may recognize. On the right-hand side, we have the Southern Cross, an iconic constellation from the Southern Hemisphere and within Australia. And on the left-hand side, we have the southern pointers. Now, these two sets of stars are two, technically three, I'll explain this soon, technically three constellations that all relate to the same story from Gamilaroi traditions. To the Gamilaroi people, the stars of the Southern Cross represent a tree called Yaran. This is another example of a constellation that is manifested from many stars. So many stars collected together to create this particular constellation. On the other hand, the two pointer stars represent two individual objects. They are Mare Mare, who are two cockatoos who follow their home, the tree Yaran, as it's uprooted and placed into the sky. This is actually quite a beautiful story, and it uses the movement of the stars in the sky to then illustrate the story once again. Now, due to the Earth's rotation, Mare Mare, the two pointer stars, constantly follow the stars of the Southern Cross in the night sky, which is just a beautiful representation of this story. So far, constellations in Aboriginal astronomy can be similar to those we see in Western culture, such that they are a collection of stars, but also individual stars can represent significant bodies of a story, like Mare Mare. Now, here comes my favorite type of constellation. The third type of constellation observed in Aboriginal astronomical traditions are the dark constellations. This is why I saved it for last, since it's my favorite. Now, one of the most well-known dark constellations from Aboriginal astronomical traditions is that of the dark emu, or the celestial emu. In Wiradjuri, we call it Gugurman. And Gugurman, if you can't quite see it yet, let me try and point it out to you. So if you can see my mouse over here, we have, underneath the Southern Cross is this dark patch over the right-hand side of the screen. This dark patch is a dark nebula known as the coal sack in Western astronomy. And this is the head. Okay, with the beak and the head there. Stretching towards the left past the two pointer stars, we have this long, thin, dusty band within the Milky Way galaxy, and that is the neck of Gugurman. And then the large bulge over on the left-hand side of the screen, this is the center of the Milky Way galaxy, and it is the body of Gugurman. So once you see it, you can't unsee it. It is fantastic. Okay, so while Gugurman is very pretty to look at, it has quite a significant use in Wiradjuri culture. Its position in the night sky at certain times of the year indicates to us when is the right time to go looking for emu eggs. So when the emu is rising just above the horizon after the sun has set, this is usually in late May or early June, Gugurman looks like it's running along the horizon. And this indicates to us that the female emu are currently running around looking for a mate. So there are no emu eggs just yet. Later in the year, after the Earth has traveled a little bit further around the sun, the body of the emu travels higher up into the sky. And when the body of the emu sits directly overhead after the sun has set, we now see it as not an emu's body anymore, but as an emu egg in a nest. And that indicates to us that now is the right time to go looking for emu eggs to eat. And this goes to show that stars can also be used as a seasonal menu of sorts. So there we have it. We have those three constellations, those three types of constellations that we observe in Aboriginal astronomical traditions. But there's more to Aboriginal astronomy than constellations. It's pretty easy to see that from a dark area with very little light pollution, the Milky Way is quite prominent in the night sky and very salient. So it may come as no surprise that the Milky Way plays a large role in Aboriginal astronomical traditions. So let's take a look at a few different views of the Milky Way galaxy from a few different Aboriginal groups around Australia. So the first view I want to show you is from the Burrung people of the Wagaya language group in northwestern Victoria. In their traditions, the Milky Way galaxy is called Warring, and it represents the smoke from the campfires of the old spirits called the Narramungatya. And the Narramungatya are represented by all the stars in the sky and are represented on the earth by Poparimble, which is a small finch. And if you think about it and look closely at this image, the Milky Way does look a little smoky. It's not just all bright and filled with stars. There are also these smoky dark bits. And these are lanes of dust and gas within the spiral arms of the Milky Way galaxy that naturally block the light from distant stars in our galaxy. So that's one particular view. From the Burrung people of the Wagaya language group, the Milky Way is warring, the smoke from the campfires of the old spirits. The next view comes from the Gamilaroi people in northern New South Wales. To them, they see the Milky Way as a waterway or a stream called Warrumbul. And Warrumbul is equivalent to the Macquarie River on the land. Now, you might be starting to see a theme forming here. If you're not yet, that's okay. We'll go to our next example, and it comes from my Wiradjuri heritage. In Wiradjuri astronomical traditions, the Milky Way is a series of waterholes, and it has the general name of Billabong. This is exactly where the word Billabong derives from. Okay, similarly to Gamilaroi traditions, the Milky Way is specifically named after the nearest river or stream in Wiradjuri land, and there are 3 of them. If you're up near the Lachlan River, which runs through central Wiradjuri country, the Milky Way is called Galare. Up north, it's called Warrumbul from the Macquarie River, and down south, it's called Murrumbidgeri for the Murrumbidgee River. Now notice the similarity between Gamilaroi and Wiradjuri for the Macquarie River. This speaks to what I mentioned much earlier tonight, that there are similarities between neighboring groups on how the sky is perceived and how the sky is interpreted. And another thing that I'd like to mention before we move on is that you may have noticed a parallel between what's seen in the sky and what is also seen on the land. A very important concept in Aboriginal culture is what is in the sky is matched and mirrored on the land like a mirage. We are all interconnected and work together, the sky, the land, and the people. So it's a very, very interconnected culture. Now, we've spoken a lot about stars and the Milky Way galaxy tonight, but did you know that the planets also play a significant role in Aboriginal astronomical traditions? Now, Aboriginal people knew that the planets were different from the stars. They studied the sky intimately and noticed that the planets moved independently from the stars in the sky. And some of the planets even outshine some of the brightest stars in the sky. Now, all the ones you can see on the screen here, these are all images taken by the Hubble Space Telescope. They are not to scale, just want to point that out. Okay, but these are all of the visible planets we can see in the night sky. Jupiter and Saturn are up in our night skies at the moment, and Mars will shortly be following them behind throughout the night. So you can try and go look for those if it's not cloudy where you are, like it is where I am right now. Now, one of the brightest planets in the night sky is Venus, which features quite prominently in Aboriginal astronomical traditions. You might know Venus as the morning and evening star. Right now, it is the morning star leading in front of the sun before it rises. And Venus was also recognized in some Aboriginal traditions as a similar morning and evening star. And it was often recognized as the same object. So they knew that Venus was a morning and evening star, swinging back and forth around the sun. Now, one of my favorite views of Venus comes from the Gamilaroi people. They say when Venus is low in the sky, it twinkles and scintillates quite violently. Now, generally, planets don't twinkle nearly as much as stars do. That's because they're a lot closer to us than the stars are. So their light behaves differently as it comes through our atmosphere. But when these planets are very low in the sky, the light has to compete with thicker and denser atmosphere. So when Venus is like this, the Gamilaroi people see it as it's twinkling as an old man called Yalingdawa who is laughing after telling a rude joke. And the laughter is represented by the twinkling, which I think is just fantastic. But the planets can also be used for navigation. So for example, the ecliptic is the apparent path of the sun in the sky, and it's the orange line in this particular picture here. And what you'll notice is that the planets and the moon all appear either very close or even on the ecliptic. This is an effect of how our solar system was created, such that the majority of planets in the solar system orbit on the same plane around the sun. This is why when we see them along this ecliptic line, they do appear to be in the line. Okay, it's quite funny. Whenever this happened maybe, I think 2 to 3 years ago, and the media went crazy about it because they said the planets were aligning when really they are always in a line. So I think it's quite funny when that happens. So this ecliptic is used by Aboriginal people for navigation at nighttime. And when all the planets are up in the night sky, even just a few of them, it is quite obvious in the sky. So like in this view here, they can use the positions of the planets to understand where to go and how to navigate at nighttime. Even exploding stars, or technically in this case, almost exploiting stars, feature in the astronomical traditions of Aboriginal people. Now, again, the Boorong people of the Wagai language group, the ones who view the Milky Way as the smoke from the campfires of the old spirits, they speak of a star that they called Kologoluik Wa, who was the wife of Wa, the second brightest star in the night sky, Canopus. And in the late 1840s, an educated and wealthy British colonist called William Edward Stambridge sat and learnt attentively from the Boorong people by writing down the names of these Boorong stars and their equivalent Western names using a star atlas, which is kind of like a paper version of Stellarium. And when the Boorong people pointed out Kologoluik Wa, Stambridge couldn't identify that star. So he noted it down as a large red star in a particular area of the sky. Now, the star behind Kologoluik Wa remained a mystery for almost 150 years, until in 2011, it was identified as one of the most massive stars known, which is a picture that I have here called Eta Carina. This is technically a picture of the Homunculus Nebula, and I'll come back to what that is in a moment, because Eta Carina is a very, very cool star. It is part of a binary star system, so there's not one, but two stars orbiting around each other in space. It's more than 4 million times as bright as the sun, but it is a whopping 7,500 light years away from the Earth. Now, the biggest star of the binary pair is a very unstable star that occasionally goes through violent outbursts where it spews out stellar material from its outer shells and becomes very bright. So basically, the star burps, and it burps out some matter. So Eta Carina did this in the 1840s and burped out a mass equivalent to 20 suns, which is just insane. So this made it go from being a background star that you couldn't really see in the night sky with your naked eye to the second brightest star behind Sirius. And I'll tell you what, I'm being serious. It's just some astronomy humor there. And then it faded again a few years later to being a background star. So it just appeared to the naked eye suddenly during this mass ejection, during this burp, and then eventually faded back down to being a background star. So right now it is a background star as well. You can't really see it with your naked eye, but you can see it through a telescope and you can see this particular nebula. So this Homunculus Nebula, it's a picture taken by the Hubble Space Telescope once again, with a few extra wavelengths added in. And it's from this violent outburst. It's the leftover of the burp, essentially. And it's a very beautiful nebula to see through a telescope. Now, the Boorong people saw this and noted down the change in the brightness, even the color of this supernova imposter, and included it in their astronomical traditions, which I think is just absolutely incredible. Like, that is observational astronomy in a nutshell, all without a telescope. So it's really great to see how scientific this is. All behind it all. It's all so very scientific, which is just really incredible. So I hope by now that you can see that Aboriginal astronomical traditions are incredibly diverse and beautiful, and we should be proud of our beautiful Aboriginal culture, because I know that I am. We have a rich history of astronomical knowledge in Australia, and while it is very difficult to fill a full 65,000 years of astronomy into one webinar, I hope that you've enjoyed learning a little bit about Aboriginal astronomy tonight. So I want to thank you so much for being here.
Thank you, Kirsten. I've just unmuted myself. That was absolutely fascinating. And my first question is, why did we only make this an hour?
I know, right?
When there's so much to talk about. That was great. So I'm going to kind of open the virtual floor for people to have an opportunity to type a question in, either on YouTube or on Zoom. And I think YouTube is delayed by maybe 30 seconds or something like that. And I'm just waiting for, there we are, we're up. Yes, great.
Fantastic.
So feel free, there's lots of thank yous coming through. Feel free to ask any questions. One of the questions that I'll start with a question, because I was interested in how far back Indigenous astronomy dates compared to some of those Greek mythology kind of constellations and those sorts of things.
Well, it's It really is thousands and thousands of years. So these stories have been passed on through generations and generations for up to 65,000 years, even possibly longer as well. There's evidence from archaeological digs from up in the Northern Territory that even put Aboriginal culture being here for more than 80,000 years. So it's just insane how long this has been around, and a bit unfortunate that we have lost some of this knowledge as well due to the unfortunate history in Australia. But I'm so glad that we get to share this together now once again.
Yeah, it's amazing. And I see that there's a couple of people hosting this at schools, which is great.
It's beautiful. It's fantastic.
Yeah. Now, I did see a question in here about shooting stars. How are shooting stars explained? Okay,
so in Aboriginal astronomy, shooting stars are very unpredictable. We do know more about shooting stars and meteor showers these days, in the sense that they are annual meteor showers. But from an Aboriginal astronomy perspective, shooting stars weren't specifically predictable. When we observe the stars, we observe the planets, we know exactly when they're going to be up, we know exactly when they're going to be around, how they're going to be moving compared to the other stars or the other planets in the night sky. But when it comes to shooting stars, because a shooting star is essentially a meteor or a meteorite, actually, I take that back, not always a meteorite, depends on if it lands on the ground or not. So it's a shooting star is a meteor, so a piece of rock and dust from either an asteroid or another astronomical object that's burning up through our atmosphere and creating this long streak in the sky. So these are very unpredictable in terms of specifically when are these things going to happen. So for Aboriginal astronomy and Aboriginal culture, they were viewed as a bad omen in most cases.
Very good. Thank you, Kirsten. Now, I've seen lots of questions coming through on YouTube, so I'm going to start with, yes, that's a good one. Why was Canis minor a dog? My son made the point it was like a lion. I think everyone
I definitely agree. So as far as I remember, Canis minor comes from Greek mythology. So who knows? They had very good imagination. Let's put it that way.
I was going to say it would be a very good imagination, wouldn't it? You're probably seeing these questions too, so feel free to jump in, Kirsten. How similar is it counter astronomy stories similar to Eastern states?
I'm not sure about that. I'm sorry. I know more about Aboriginal culture than I do other cultures, but I would love to learn more about other cultures around the world, because even not just Australia, around the world, the night sky is so paramount to the way that we live. Like, we are stars in a sense. The great Carl Sagan said that we are star stuff. We are a way for the universe to know itself, because all of these stars, these exploding stars, even the almost exploding stars, the burpy stars, let out matter that creates us. So the calcium in your teeth comes from exploding stars. The gold in your rings comes from merging neutron stars. There's everything almost from hydrogen, a bit of helium and a bit of beryllium, everything heavier than that has been created through stars.
It's a beautiful thing, and I thank you for quoting Carl Sagan there, one of my personal heroes as well. So that's good. Yeah, great. Now I'm looking up and down from the screen because I'm looking at YouTube as well. Now, what else have we got here? What do Indigenous people believe about our moon?
Our moon?
Are there stories around the moon? Yeah.
There are definitely stories around the moon. Would love to share with you a story about how the moon was created within the dream time from Wiradjuri culture. It's such a beautiful story and I absolutely love it. So in the dream time, Bayami, the creator spirit, had only the company of 4 animals. He had the kangaroo, an emu, koala, and an eagle. And for a very long time, all of these animals lived harmoniously on the land without any issues or without any quarrels. But one day they all started bickering at each other, saying, no, I'm the best, I'm better than you, and having these large bickering fights, essentially. And Bayami sees this from his home in the sky and comes down from his home in the sky with a solution to make sure that they know who is the best. And so he says to them, okay, if you're going to show to me that you are the best, show to all of us that you are the best, you will show us your greatest achievement. What can you do that will prove that you are the best ultimately out of everyone. And so one by one, each of the animals go on and show what they can do best. So the kangaroo hops very high. The emu runs really fast. The eagle flies so high and then just glides back down. And the koala, I love when I'm telling this story to young kids, because I always say the koala sleeps. But no, the koala does not sleep, although it does sleep a lot during the day. It climbs to the tip top of the tallest tree and is not fazed by the wind blowing it around. So as all of these animals do it, none of them are necessarily better than the other. They're all great in their own way. But then Bayami, the one who created them and gave them life, comes along and with his boomerang, which we call bargain in Wiradjuri language, comes along with his bargain, his boomerang, and throws it so hard that it flies through the sky, changing shape, has a life of its own, changing brightness, and just completely mesmerizes the animals. And so they realize, oh, like, we should probably respect our elder here, because they've given us life. They've given us, the understanding of the world that we understand today. And Bayami catches his boomerang, catches his bargain. And then after that, just to drive home, just to make sure that they know that Bayami should be respected as their elder, Bayami throws his bargain once again and throws it so hard that it flies through the sky and follows the sun over the horizon. Then the next night, after the sun has gone down, a little crescent moon appears in the night sky, which is what we call bargain. And that's the Dreamtime story of how the moon was created in my Wiradjuri culture, which is just, I love it. It's a beautiful story.
Yeah, they are beautiful stories. And I think someone's asked the question about whether there is actually a children's book or even just a book that captures these Indigenous astronomy stories and linked to those amazing pictures from the Hubble. You're quite right.
I don't know if there are actually any children's stories out there at the moment. But if you do want to learn more about Aboriginal astronomy, you can go to www.aboriginalastronomy.com.au. It's a great resource for you to learn more about Aboriginal culture. When it comes to the website, you can learn by what region. So you can go to Wagaya language group, you can go to Waterman, Gamilaroi, and learn based on the group. Or you can learn by subject. So meteors, shooting stars, constellations, planets, you name it. There's lots of information that still needs to go up because, like I said, we've lost a lot of the information and we need to recover the knowledge as best as we can and as respectfully as we can. But there's lots up there already, which I would definitely recommend going and have a look at because it's really, really cool.
Yeah, great. Now, someone asked a question and I have to ask it for you because it was from a 10-year-old girl, I think, who said, how did you first get into astronomy? What sort of sparked it for you?
Oh, well, I'd definitely love to answer that question. So when I was in primary school, I wanted to be a meteorologist. So it was definitely always about the sky for me. But when I was in high school, in about year 9 or year 10, my science teachers took my whole year group on an excursion to go see the Hubble documentary on the IMAX theatre in Sydney. So I remember just sitting there, smaller Kirsten, sitting with these one-size-fits-none 3D glasses slipping off my face, just looking up in awe of these fantastic photos taken by the Hubble Space Telescope, which, by the way, right behind me right now is another one of those fantastic photos. This is an infrared image of the pillars of creation taken by Hubble, and it's just, oh, how could you not love this stuff? It's so cool.
Absolutely. Beautiful. And I must say, your background is so much more impressive than my cupboards. So well done.
Thank you.
On that. Now, what else have we got? So many questions coming through.
There's so many. It's fantastic.
It really is. Well done, everyone. What do Indigenous people believe about eclipses? That's a good
eclipses. So they were able to predict eclipses as well because they understand how the sun moves and how the moon moves as well. I don't know any specific stories about solar eclipses, I'm sorry, but they were definitely predictable by Aboriginal people, which is, again, astronomy right there without a telescope. It's just, I'm amazed by it every single day.
Absolutely. Now, there's lots of I think you've sort of answered this question, but it was around good resources for these kinds of stories and Indigenous astronomy information. And I know as part of my very rapid research to host this, there's a website which you may have mentioned, but it was a good one that you're on, your sort of biography is on as well. Did you mention that one?
Yeah, I think that's probably the aboriginalastronomy.com.au website.
Yeah, I think that's it. Great. Yeah, that's a great place to start, I think. Patricia, there's the 10-year-old girl. Sienna, is it? Sienna, perhaps.
Oh, they're fantastic.
Yeah, great. I'm glad we got to your question. Now there was one about here about, was Aboriginal astronomy something that was read by a particular, stories were told by a particular member of the tribe, like a storyteller? Is that sort of how it was done, passed on?
So our stories are passed on from generation to generation. So they are passed on through song, they're passed on through stories like I've shared with you today. In terms of who specifically is in charge of those stories, it's definitely the elders who pass on those stories from themselves onto different generations. In terms of the specifics, I won't be able to speak on that tonight, I'm sorry.
Oh, that's good. This is a really good question. Do you find any conflict between the Dreamtime stories and what science has taught you, and how do you separate that? Because, I mean, you're training as an astrophysicist, aren't you?
Yes, definitely. So that's a great question. And it's interesting because I've had this passion for astronomy and the skies for so long. And I've been learning more about my heritage and more about my family and more about the culture as I go along to learn more about the universe from an astrophysics point of view. And there's not so much a disjunct between the two, it's also a melding of the two. So on one hand, you have the stories, which are very much stories with lessons and all of that in it. But then when I'm hearing these stories, and when I'm hearing them over and over again and hearing them multiple times, by the 5th or 6th time, I realize, oh, hold on a second. That relates to this astronomy thing. That relates to this astrophysical thing. And then it just blows my mind even further. So for example, with the Gamilero story about Yara and the tree and Murray following the tree in the sky, I realized that after maybe 2 or 3 times of listening to it, I thought, oh, wait a second. Let me think about how the stars move. Oh, wait, that is actually illustrated in the night sky. So it's a bit of both. Like learning the stories and from a cultural point of view and a spiritual point of view is great for myself. But then when I realized the astronomy part ties in, like this astrophysics is thinly veiled within these stories and observational astronomy is thinly veiled within these stories. So there's not really much need to separate it in that sense.
Great. My 8-year-old son, Jonty, would like to know how stars were made in Aboriginal Dreamtime. So
I love this story. In Aboriginal Dreamtime, I'm not so sure about that, but I can answer how stars are born in terms of an astrophysics point of view.
Love it. Go for it.
Our sun was formed in something like this. And I love that this picture has just helped me throughout the night. So what we've got here, the pillars of creation, is a dusty region of dust and gas in space. And that's where stars form. So it's a stellar nursery. So essentially you have these big clouds of dust and gas. And within it, it's not like a uniform region of cloud. So it's not completely the same density throughout, kind of like a glass of water, for example. Instead, it's kind of like a glass of Milo, where you've mixed in the Milo and there's clumps all through it, okay? And within these clumps, there's more stuff, and so it has more gravity. It has a stronger gravitational pull because there isn't just more stuff there, more mass. Now, while it has more mass, has a higher, stronger gravitational pull, it pulls in more and more and more and more stuff, more and more matter, until eventually it starts to spin, and that's what we call maintaining angular momentum, but I won't go into that because it's a bit too sciencey, a bit too physicsy. Unless you want to continue through the second year astrophysics, you can learn about it then.
I think we all do now, Kirsten.
We all do. We all want to now. So as all of that stuff is coming in and spinning around, more and more stuff is being put together. The heat, the temperature is heating up. And as it goes, it's spinning around. Eventually, when it gets enough stuff, it has enough gravity to push it all together. But then the temperature ignites nuclear fusion in the center of the star. And that's when the star is born. Okay, when it's fusing hydrogen into helium and then going on to do more and more exotic stuff. But then that temperature blows it up like a balloon. Then eventually the pressure from the inside, from the temperature, balances the gravity on the outside. And so it is then in hydrostatic equilibrium, which is another big set of physics words there. But then by that time, it's a star.
Great. Love it. And I love, I remember learning about the difference between nuclear fusion and nuclear fission in terms of what we can do. And I think of, correct me if I'm wrong, but in terms of the Large Hadron Collider, that was part of the work that was being done to try and create some kind of fusion, ongoing fusion energy source for us as well.
I think so, yeah.
Yeah, as part of what they were doing. Sorry, I just nerded out there from that person, but
we're all okay. We're happy to nerd out. We're having a full-on nerd out right now.
Someone's asked, and it's a good question because I think it leads to a whole lot of other aspects around how suns operate, is how is gold created by stars? Someone's asking about how, because everything is created by stars. So
yes.
And over to you, Kirsten.
Excellent. You can see just with the excitement on my face that I am ready to give this explanation. I love this explanation so much. So some of the heavy elements like silver, gold, platinum, all those heavy metals, okay, all of those are generally made within neutron star mergers. So what a neutron star is, it's the remnant core of a very massive star that hasn't quite been massive enough to turn into a black hole at the end of its life, but it's turned into a neutron star instead. Neutron stars are very, very dense. They're, as far as I'm aware, the most dense thing in the universe before black holes. And what happens is sometimes they are in orbit together and eventually they merge, which sets off what's called a killer nova. So you've heard of supernova before, but now this is a killer nova. So it's a huge supernova that produces a huge amount of energy and a huge amount of temperature and a huge amount of light. And in 2017, I believe it was, we measured and detected gravitational waves from two neutron stars colliding. And then later on, it was such a cool event. Stuff. So exciting. And even more exciting because when we detected those gravitational waves, they sent out an astronomer telegram, which I like to call an astronomer stellogram because that just sounds so much cooler, so much more on point.
True, I like it.
And within this astronomer's telegram, it told all the astronomers, okay, this is where we found it. Point your telescopes here. Try and find this particular electromagnetic counterpart. So this bright flash from these merging neutron stars. And we saw that, which enabled us to understand more about what this thing was and what it produced. And by looking at a telescope, looking through a telescope at this particular object where these two neutron stars collided, we can take what's called a spectrum, which is the rainbow essentially. And within this rainbow, we can detect certain lines because all the elements in our periodic table have their own specific fingerprint, which tells us exactly what something is made of. So if we point a spectrograph towards the sun, we'll see it's made of lots of hydrogen, lots of helium, and some other stuff too. So when we pointed our telescopes at this merging event, we saw that it's made of lots of gold. And within this particular explosion, within this particular killer nova, almost 10 times the mass of the Earth was created in pure gold. Just imagine 10 Earths of pure gold. So that is where gold comes from, essentially, from merging neutron stars together. But let's just wait a moment and think about, what does 10 Earth masses of gold look like? Or in terms of money. So let's say in today's current market, I know if we had that much gold here in the world, the market would just crash, but let's just ignore that for the moment. With today's current value of gold, that would equate to about $100 octillion, which is equivalent to a 1 with 29 zeros after it.
I was going to say, you made that up.
It sounds like it, doesn't it?
Yeah, it does.
Such an inconceivably high number. But if we were to imagine $100 octillion in $2 coins, I wonder if I have one on my desk. I don't think I do. But imagine $100 octillion in $2 coins, and you stack those $2 coins on top of each other flat like this. That would create a stack that's long enough to go from the Earth to the point in space where these two things collided and back again, I think about 50 times. Just
That's great.
Crazy.
Yeah. I love those comparisons. They really give it some context, don't they?
It does, but in the same way it doesn't, because it's like, that's still really, it doesn't help much, does it?
That's great. Just going through. Now, do we know if the planets have names in Indigenous traditions? That's a good one.
Yes, so they definitely do have names. We have, for example, Yalingdawa for Venus from the Gamilaroi traditions. There are lots of other names as well, but none that I can remember off the top of my head. I'm very sorry, but and I showing my cards a little bit here. I did actually write a paper on the role of planets in Indigenous astronomy. That was maybe 3 or 4 years ago, but there are lots of names in there, I promise.
You're forgiven for not remembering. Your head is full of very important things, Kirsten.
There's so much
that's
space
all
stuff
good.
in here.
Yeah. Can you, Carl had asked, can you share some more about your own galactic archaeology, Indiana Jones style work and / research?
Yes, I can. So essentially what I am doing is the first part of the story is we're going to be observing 2 types of stars. They're called red giant branch stars and red clump stars. These are 2 types of stars that are near the end of their lives. They've evolved off what's called the main sequence. So they're quite old. They're continuing on their life up through the stellar population, essentially. But the thing is red clump stars are what we call standard candles in astronomy. So they shine approximately the same brightness with the same temperature and same observables that we can see through a telescope pretty well. So we can use these particular stars to accurately map the Milky Way galaxy. So that's what I'm doing so far. We're trying to observe these red clump stars and observe some red giant branch stars, where the red giant branch ones are not standard candles, but these 2 types of stars are very hard to distinguish between the 2 in terms of just using spectra. So using a spectrograph, like I talked about when with the neutron star mergers. So what we're doing towards the end of this year, and I'm excited, but also I'm not too sure how to feel about it, but I have telescope time right over Christmas. So kids, I'll be able to watch for Santa as he's flying by. Okay, I'll make sure that I put out, I'll take a photo for you and I'll put it out online. Okay, but we'll be observing over Christmas and trying to distinguish these two types of stars just with spectroscopy alone, which is going to help us map the Milky Way galaxy very accurately, hopefully within the next 4 years by the time I'm done.
It's amazing, fascinating stuff. There's a question here. Someone was asking about getting a copy of the paper that you wrote, but I wasn't sure whether it was still available or...
It certainly is available. So it is on the Aboriginal Astronomy website. So if you go to learn via topics and go to planets, it's down the bottom of the page there. So you're more than welcome to read that.
Great. We mentioned gravity earlier on, and about neutron stars and black holes. And I know that recently there was the first pretty much kind of photographed black hole, first photograph taken of black hole, which was also very, very exciting. I was interested in your take on gravity, because one of the things that identifies a black hole is that it's one of those cool things that black holes have so much gravitational force that they bend even light. Even light is sucked in to them. But gravity is a force that we are unable to kind of observe. And I was interested in your sort of take on that. We can observe the effect of it, but it's not actually observable.
Yes, so gravity is kind of like an invisible force. It exists everywhere, which is quite interesting as well, because a lot of people say there's no gravity in space, when in actual fact, there's gravity everywhere. So if we do a quick crash course into gravity, when we look at universal gravitation, we see that when we look at the relationship between the force due to gravity and the distance from whatever object you're talking about, that distance, the force actually only gets to 0 when you're at an infinite distance away. So gravity technically exists absolutely everywhere. Even if you were the only object in the entire universe, the gravity that you possess, just because you possess mass, will still extend to everywhere. So fun little fact for you guys there. But I totally agree. We can really only observe observationally in terms of, light, gravity at a kind of at a distance, or the, like you said, the effects of gravity. So when we look for the black hole, for example, we're looking at the accretion disk, all that hot orange stuff around the black hole is the accretion disk and the stuff that's orbiting around the black hole that's super, super fast. And we can see those effects through that image. We can also see gravitational lensing, which is another really cool thing. So gravitational lensing, we can see that in really massive galaxy clusters, because there's a great photo of the Abell 1689 galaxy cluster, where when you look at it, it's mostly just bright orange blobs scattered around the view, which are the bright old galaxies that exist within the cluster. But then there are some of these blue streaks that kind of, if you connect them all together, it creates a nice round circle around the center of the cluster. And that's galaxies that exist behind the cluster itself. And their light is being bent and warped by the huge mass and that gravity of that cluster. So there's lots of really cool things we can do with gravity without actually changing gravity in any sort of way.
I feel my mind expanding as we're talking,
yeah.
Kirsten. Now, my internet just jumped a little bit, but I tried to jump in with a question there about someone asked whether you'd thought about becoming an astronaut and getting out there amongst the stars.
So what kid wouldn't love to be an astronaut at some point, right? Now, space is kind of terrifying, I'm not going to lie, but if I do have the opportunity of being able to go into space, there are two things that I would love to see. I would love to orbit around our pale blue dot and orbit around the Earth, because that would be really awesome to see Australia from space, see, the lights of Europe from space. I think that would be really, really cool. But the other thing I really want to see, if I ever get the chance, is to go on an expedition to go swing around the moon. Because then as you swing around the moon, you get to see the far side of the moon for your own eyes, instead of just seeing a picture taken by a NASA orbiter. You can see the back side of the moon for your own eyes, but also as you're coming back around the limb of the moon, you'll be able to see an iconic view that the Apollo 8 astronauts saw on Christmas Eve many, many years ago. And that was the Earthrise. So you see the moon surface and just the Earth rising above the surface, which
just beautiful.
Gives me chills just thinking about it. And being able to see that in person would be really amazing. That'd be a dream come true.
Fantastic. The other photo that I would recommend, if people haven't seen it, is the blue. When you mentioned the blue dot, the blue dot photo that I think was taken from the Voyager.
I think so.
Looking back, and it's sort of like the Earth is one pixel in this massive kind of spacescape.
That's it.
Which is incredible. Yeah. I can't believe it, but we've already got to 8 o'clock.
Oh wow. Time has just flown by.
I know.
We've gone close to a black hole and time has just gone real fast.
That's so true. So I guess at this stage, there is someone saying, is there a part 2 of this? And we'd love to have that at some point. But I want to say thank you so much to you, Kirsten, and thank you so much for all of the excellent questions from both YouTube down here that I've got on this screen and Zoom up here on this screen. I think everyone's been blown away by your stories, your knowledge and your enthusiasm, and you're just a great communicator. So thank you so much for being part of this with Goldfields Libraries.
Thank you so much. And for those who still have questions about astronomy and astrophysics, you're more than welcome to reach out to me on Twitter, Facebook, Instagram, or TikTok. I'm also on TikTok as well. You can find me at AstroKirsten. So more than happy to answer your questions at AstroKirsten on all of those social media platforms. Thank you all so much. This has been beautiful. I don't think I'm going to be able to wipe the smile off my face for at least an hour after this is done.
That's great. And I think we peaked out at like more than 280 people across both formats. So fantastic.
Amazing.
It was a great crowd. So thank you, everyone. And I can say to everyone, I will lobby Kirsten to come back for a part two. Part two, yes, please. Yes, that's more, please. That's right.
Oh, thank you.
Yeah. So, yeah, fascinating. And thank you so much. And thank you, everyone, for a lovely evening. I have had my nerd cup filled very nicely. Thank you. Thanks, Kirsten. Thanks,
Thanks, everyone.